Let's introduce Keerthana. Keerthana Krishnan is a software engineer working in Munich, based in Munich. And I'm really excited about this talk because I'm a big believer in we should choose the right tools for the right jobs. And it's not necessarily the same tool that works for every kind of project, and a diligent kind of choosing process is really important. But also, once you've chosen the tool, then using that right is also important. And you know, with some of the modern frameworks, we don't always hold them right, and sometimes they don't emit the best performance. So with a talk about optimizing your use of React, and I think many other things along the way to do with performance, are you ready to go? Let's do it. Please, a giant round of applause for Keerthana Krishnan.
Thank you, thank you. Thank you, Perf. Everybody looks happy. Thank God I got the slot after lunch. Nobody is cranky anymore. Yes. So my name is Keerthana. I am from a place called Cochin in India, but currently I am based in Munich in Germany. I am a software engineer working for a product called Yamdu. And a little bit about Yamdu. So what we do is, the easiest way to kind of say that is we are like Jira, but for a media project. So if you are going to direct the next Thor film, for example, you'd want to use Yamdu to like maintain or manage kind of the planning that you have for it. So you can upload a script, and from the script you can say, okay, these are the locations that you want. Asgard might be difficult, but maybe Norway. And you have a few roles, you have a few characters, you have a few locations. And I'm just saying this because I will be using a couple of scenarios that we faced later on in this talk. So when you see Yamdu and when I say scenarios with some characters and roles, it doesn't feel out of place. So that's kind of that, and that kind of real world example is what I want to talk about with you today. Because I don't think, okay, so just to get a temperature of the room, how many people here have worked with React? Show of hands. Oh, that's a big crowd. How many people here are happy that they worked with React? Okay, there are still some hands. I'm very happy to hear that. So, some caveats before we start. Even though I do stress, again, that I do have some React-specific examples, I do believe that some of the concepts you can work with no matter what framework that you have, but especially the examples, they will be React-specific. And I would like you to choose, or I would like you to focus more on the principles behind it. So I'll be deep diving into why some of these things are worse for React. So hopefully you can still get some takeaways from that. And just to set the agenda right, so I will be handling 3 things here. What do we use to manage the React performance, which is like the easiest answer. Everybody sitting here, I think you already know. Why is it important, and how can we improve it, right? So what do we use? Gimme, there's 3. What are the 3? Come on, you guys, you had lunch. What are the 3? We have LCP, we have FID, we have CLS. Those are the 3. I hope you guys know that. It would be really sad if people didn't know that by now. And specifically on LCP and FID, or INP now, Nishu already talked about that, so I do have a couple of slides, but I will be going a bit faster because that was the talk right before me, and you cannot forget it. And of course, why is that more important? Because compared to the lab-based stuff, you have more user data, so you have more, even if you have your website, and I do hear it from my dev friends. I come from a very dev background, and they do have things that say, oh no, we run it on Lighthouse and it looks good, so why do I care? Because this has more user data. It's real-world user data, so these are kind of the metrics you should care about a little bit more. So everybody knows about Web Vitals now, but I would really like, I'm not sure how many people have seen this talk from Dan Shapir or read this article. So he did a very interesting study because, to be honest, Web Vitals are still quite new compared to the age range of the internet, right? The span of how long the internet is. These are quite new metrics. So when Dan did this kind of an analysis on after they were introduced, he noticed some really interesting kind of patterns spread across the different frameworks. Now, I'm not going to talk about all those patterns. I will be talking very specifically about how React behaves, but I would highly recommend that you go find this article. It's linked in my slides, read it, and I don't want to spoil it. So across all of the websites the percentage of the web vitals which show green, which means they have good performance. These are the numbers that they've shown for this particular time period that they studied. And very key things I would like you to notice. One is this is only for the United States. So compared to the global amount of data that you can collect for this kind of a metric, he very specifically focused on the deep set of the United States so that we wouldn't have kind of the variation in latency or network or the kind of things that could happen when different locations have that kind of a problem. So it's that one geographic area. And also the client is mobile. So across the spectrum, mobile is still the most highly used device, but we still have desktop. Very recently, I found gaming consoles. So a bunch of things in which people use the internet on. Mobile is still, by and large, the most populous. So here's how the data shakes off for everybody. And now, interestingly, when you pull it down to the top 1 million, which arguably top 1 million means the top developers are working on it. So we expect an improvement in the statistics. And however, React is the only one. In the earlier slide, if you noticed, it used to be 36%. When you pull it down for 1 million, it goes down to 34%. And that 2% of a drop, when it comes to 1 million data points, is not a small drop. So when you pull it down to the top 1 million website, why are React websites doing worse? Arguably, these are the websites that have more top-tier content or top-tier talent working on it, so we expect those metrics to get better. So just to present the other important conclusion, LCP scores actually do not vary much for React. They do remain quite same, and LCP is, to be honest, the least that you can affect via a framework, right? It has more of a backend influence on it, I would say. So that would be also the metric that I would be touching on the least. And we have a wonderful talk tomorrow by Estelle. I'm just mentioning some stuff there. I will not be going into it too deep. And a comparison that Dan made was with Vue. So Vue, when you compare it with React, when you go very specifically into the metrics, Vue does better in some metrics compared to React, and we will be looking into why that is the case. FID, again, asterisk, that's changing soon. But when they did the analysis, FID was still FID, so I feel like I need to say a note. FID was kind of meaningless, and not my words, because all of the frameworks kind of had a pretty good score for FID, which means all of the metrics had pretty performant first delay, but the difference came in when you measured over the loading of the page. So again, FID changing soon, asterisk. So when you limit for 1 million, what are some of the key things that we notice? So the amount of JavaScript downloaded increases when you filter for the top 1 million websites with the most traffic for the United States on the mobile clients, which means arguably these are the most popular website, which means arguably they have more features, more expectations from the users, more users using it. So consequently, the kind of libraries that they use and the features that they give, they do have more JavaScript usage. But at the same time, compared to sort of previous versions of the study, I believe, these newer websites, they download significantly lower sort of media data, not just images, videos, which means images, which used to be one of the biggest drain on performance, things are getting better. People are kind of paying attention to it. So if we do take images out of the equation, if we just focus on development and data and rendering, how can we do better at this, right? So essentially, when React sites actually go down in terms of like performance improvement, when you limit to the top 1 million websites. Again, FID. We are sort of phasing it out. Again, you should be remembering this. This was just the last talk. And the difference between FID and INP, I will touch on it again. But I just want to stress that this is, at this point, some of the things I will be talking about is just my hypothesis, because INP has not come into play yet in terms of a stable metric. So I will be giving you my assumption about it, but once the data comes in is when we would really have more kind of concrete conclusions on this topic. So, as I mentioned, that was very much a deep cut into one significant data set, right? When you zoom out of the United States and go a bit more globally, so this data that I have in the dark blue, it's from 2018. So we are hopefully remember 2020, there was this little thing called the quarantine and stuff, and that did in a lot of places really push digitization in previous places where digitization was considered, okay, I don't need the internet, right? I don't need to use it. I have cash, or I can just talk to a person. That kind of scenarios changed unimaginably. And I say that as somebody who's from India and who has experienced this. Like, my grandfather asked me, hey, how do I install Airbnb? He had a Nokia. That was a very weird discussion. So, in a lot of ways, mobile, when you zoom out of the United States, is the leading use case in a lot of websites, and it is being used by increasingly diverse population, which might not have the same kind of access to the internet and the same kind of, let's say, access to quality internet. So those are also important metrics when it comes to this kind of a consideration. So I had a talk in 2019 about this topic, and I went back and watched it kind of recently, and I felt like, wow, some of the things I said do make sense. Cool. And I don't want to toot my own horn or anything, so if you are interested in this kind of zooming out kind of reference point, I would still ask you to go take a look at that. But this is what it comes down to. If you are building for a global audience, the world still uses the internet with very crappy speeds and very slow internets and unimaginably innovative ways. So I would recommend checking that out if you're interested in that kind of a deep cut. So as you see, I'm going to touch upon these things, but as a 50-minute kind of a talk on performance, I do not, unfortunately, have the time to deep dive on any of these topics individually, but hopefully I can give you some thoughts and vibes on these very specific kind of ideas. So I did promise you a scenario, right? I'm bringing in my scenario now. As hopefully you guys remember from about 20 minutes ago or 10 minutes ago, I do work with scripts, managing a media application, and managing a media project. So this is very much our CEO's vision board scenario, the next John Wick movie, we wish. It's not John Wick right now, but he really does wish. So assuming that we do get our hopes up and we do get it, assuming that we do get the next John Wick movie and we want to manage that kind of a media project, how can we? And here's where I'll be going a little bit deeper into the React-specific cases. So this, I just wanted to show like a flow chart of how the data would be like. So what would be the different kind of classes that we have? We have a bunch of roles. John Wick is a role. We have Winston. We have the little dog. I hope people know at least a little bit about John Wick. Shoot, 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 shoot. We have some props. We have some really amazing location. Things that I've not added here. We have stunt work. So that has its own set of data and parameters to manage, which are much more complicated. You have shooting dates. And again, I've only included the very simple stuff. So if we include stuff like shooting dates, those could change. For example, today the weather is unimaginable. You do not want to shoot stunts in a weather like this. So that kind of reimagining of a real-time situation is very complicated when it comes to such a large data set. So first metric that I want to deep dive into with these kind of scenarios in mind. It's very easy to talk about performance when we just have a sample application and we can just reference some things from the documentation. But that's why I want to go through a scenario with some complicated data points with you. Again, LCP is the metric I'm going to touch on the very least. And why is that? Because, again, a lot of the things that you need to do to improve on your LCP would be things that kind of has a bit more of a backend influence. Mostly it will be about eliminating load delay, improving your network latency, reducing your resource load, stuff like that, which I don't know how much as a React developer you can influence those things. But just to do my work as a speaker, I would be amiss if I did not mention at least a few steps. So going back to my scenario, what would I be doing if I wanted to have a better LCP score in my application to manage a script? I would be, of course, improving a server response time. So that would include something like a CDN. I would be minifying my code. I would be optimizing my media files. So I hope everybody knows about, like, if you're using a standard React application, I assume you're using Webpack. So you can go through Webpack, talk about how you need to implement a production build, do some tree shaking, stuff like that. Again, I'm just touching on these top points. I will not be going in too deep on any one of them. These are all kind of connected to LCP at this point. Moving to something that we can actually control with React, let's talk about CLS. CLS is a cumulative layout shift. So I assume people at least know the top level of what CLS does. But just in case, I'm going to go a little bit deeper into this. So what CLS measures is like an unexpected shift of the layout for a user. So if you are going into an application, for example, you're coming into my application, and you're at the login page, and you're like, click, I want to upload a script, and it goes to the script page, that will not be counted in CLS because that is a user interaction. It is not unexpected for the user. It is something that happened as a reaction to the user interaction. So that will be what INP covers. So let's be very clear on the distinction between those. So how is it measured? So the browser looks at the viewport size. So here most of my examples will be in mobile, because again, that's my use case that I've chosen to work on, but it will be working pretty much exactly the same on desktop, I think. I hope. So one single unstable element, so how does CLS make a difference? And I want you guys to keep this kind of a screen in mind, so that when I bring the React-specific example, you can see how this kind of shift would make a difference. So I have, at first, 2 boxes, one with white, one with green, and then I bring in something which a little button pops in. It's a very dynamic DOM element added to the first box. Now, the first element, the white box, it doesn't move. It has the same starting point in the first screen as the second screen. So it is not considered an unstable element. The second DOM element is the green box. That does move. It goes from almost the middle of the viewport to a slightly lower, right? That's where that calculation comes in. Now, you might be interested in the orange little button that comes in. Technically, that is not an unstable element because it did not exist in the first frame. So we only consider the elements that actually moved. If it did not exist in the first screen, then technically it is not unstable because only if it moved and it just popped up in the second one. So when it comes to multiple unstable elements, looking at the previous example, we can see only the first one, cat, has remained exactly where it was in the previous screen. In the second screen, we have a few creatively named predator animals who just pop in unannounced, but they are all elements that did not exist in the first screen, so they cannot be considered unstable elements, right? But there are a few, starting from dog all the way down to zebra, which existed, and they moved individually down, down, down. And in this case, the CLS calculation will only take the maximum distance that it moved, so which is the blue arrow here in this case. So having that kind of a calculation in mind, and I'm hoping that since a lot of people have worked with React, you can already get what a React context is and the use cases for a React context, right? So I have a bunch of data that I want to manage, and in the case of my scenario, the screenplay is the source of truth. Right? Once I upload a screenplay, that is where I get all my roles from, my costumes from. They're all dependent on the data I get from the screenplay. So then, a React context is very ideal for that kind of a top-down approach, where there is a single source of truth, and once you have to change the source of truth, everything connected to the source of truth should re-render. Right? So the minute I change the screenplay from John Wick to The Dark Knight, all of the other 4 should change because the roles are different, the costumes are different, the makeup is different, the props are different, wildly different. Each one of those things will be impacted. So screenplay is a very good use case for a React context. Yes? You guys are with me so far? Yes, I see nods. Fun. that's when we get a feature request. Hey, we would like some versioning of the script. Now, as anybody who sits in the front row would know, there is no way in which we can have only one version of a talk. You start writing a talk, and there are multiple versions, which is what our clients told us. Hey, it's very nice. This is a very useful application, but we have multiple versions of the John Wick screenplay, and we would like to maintain the different version and some editing. But that is when things go very wrong, because the minute I upload a second version, everything re-renders. But that's how I wanted it to work. I wanted everything to change when I changed something in the screenplay. However, how can I do just a conditional upload? Now, if you wanted to do that, clearly React Context is the wrong data kind of management tool to use, right? And I wanted to show a scenario like this where it started off being the perfect thing to use. It started out being the right tool to use from the React toolbox. But as the feature creep comes in, as you get more feature requests, you can see how, okay, this has started out exactly how I wanted to do, but then it changed into something that I definitely did not want it to work like this. And this is a very simple example, but it can be only after 3 or 4 iterations down the line you come to a point like this. So what will I do in this kind of a scenario? I will come to that. But before I talk about that, let me talk about some other conditions for the CLS. So the React context re-rendering is a very small example. And the thing about React context is that when you change anything in the context, the data that you store, everything connected to the context re-renders. So that can be, if the user doesn't expect it, it can be quite jarring, especially if you have images and things like that in your data that you have put into your React context, which is also why in my slide with React context, these are some of the ideal use cases for React context, those conditions where you do want everything to change. So in case you have authentication, light mode or dark mode, or for example, localization, your user is going from, they are originally based in the US and they flew to the Netherlands. So you want some localization stuff to change based on where the user is accessing it from. So those are still ideal cases for React context, because we do want those data to re-render at that point. But if that data changes too much, then React context becomes the worst use case for that kind of data management. And so that's a very simple example, and here are some more CLS kind of scenarios that can come into play. One, as developers that we might not think of, is kind of like images or third-party stuff that while development we do not face, or even if our testers do face, some stuff is cached and we don't really see or experience it the way our users do it, because it's cached, it's third-party stuff, and I really don't have to touch that. But those can really be some CLS gotchas that come down the line. So some more, and I want you guys to understand the principles of it and see the different cases in which this happens, because there really is no one way to fix it. It really depends on your application, your data structure, what you're trying to do. I really cannot give you like, hey, if you have CLS, do this. Because if that existed, somebody smarter than me would have already done that by now. So this is very much a think about all these scenarios. This is all the way in which your code can go wrong. I am very sorry. Glad you had lunch. So let's talk more about ways things can go wrong. Images without dimensions. I think these are the simplest of cases. Of course, when you add in an image or any kind of media, you do want to have that kind of section in your viewport in mind, have height, width, whatever it is given there properly. Ads, embedded stuff, iframes, those are all. Iframes would be, for example, if you have a Google Map plugin coming into play or a YouTube coming into play. Those are all iframes which can kind of have an unexpected layout shift when that iframe pops in or when that widget loads, right? So do keep the space that you want in mind when you develop stuff like that. Top left animations, again, as I mentioned, each one of my slides has things where you can deep down into how performant things can be, and I really is out of my scope of my talk right now, so do keep those things in mind. One thing I can say about animation is that animation can be a really good way to improve your CLS score if you use it the right way. So if you have kind of something where there is a user interaction, the user has clicked something, and it's taking a lot of time to load it from the server or something like that, you can have a really good animation in there in place to keep that kind of space hold, so that when the data comes in, if it is out of the sort of time limit that the CLS calculation usually takes in the browser, it holds the place, and that CLS calculation doesn't take hold. It kind of smooths things over that way. So using CSS transform as a method. Web fonts are, again, a huge kind of opportunity or a threat, depending on how you look at it or how you use it. So these are all fronts on which your CLS can get better or can get worse. So in my scenario that was previously, React context was screwing everything up. So I brought in Redux, as a lot of us do, right? And in Redux, I have all the different things that my screenplay was supposed to do. They are all individual units now. The roles have its own object. The costumes are its own object, right? And they're all separated in so that we don't have that kind of a re-rendering when a central point of contact is changed. So if I wanted to change something in my script, if the only thing that changes is the location for it, I can just send a second version of the locations API or something like that from the server, and I can just update the locations data that is connected to my project, right? So this is, in my scenario moving forward, I will not be having that kind of a centralized data flow. I will be having them separated out. But don't worry, there are enough problems that happen in this scenario as well for us to be entertained for the rest of the talk. More scenarios for things go wrong. Yes, displaying a large collection of data. This will come into play in one of my future examples. But when you have a large set of data coming in, so when you use something like lazy loading or caching, so those were some things that I recommended back in my LCP slide, which I don't know if you remember because there was a lot of content up on the screen. So that is point number 4, if I'm not mistaken. Yes, there you go. So things that you do to improve one metric can end up causing something for the next metric. So if you do caching and lazy loading, okay, my LCP score is improved. Going down the line, when you have a CLS score and you have lazy loading, oops. I wanted to show a very specific example here, right? So when you have lazy loading and you have not done it properly for a large list of data, it pops in at various times in between because it was supposed to, but you have not put in the kind of space that you needed, right? Is it performant? Yes, the data came in, you did not load too many in the first go around, but for the user, the visual stability is not good. It's jarring when you are scrolling through something, suddenly more data kind of pops in. We have all used certain social media platforms, we will not name names, where you are scrolling through things and suddenly pop in or goes back up. I'm not going to name names, but we all know who we are thinking about. So everybody makes these mistakes. That's all I'm saying. Don't want to get sued. So having large amounts of data is, again, there is no simple way to do it, because if they could do it, those guys would have done it already. So it really matters on how your data is, how you can manage it. And one thing I would like to say, sort of, which might not be something that I put on a slide, but I do notice it from my experience that sometimes when CLS issues come to front, it is something that my designer thinks, hey, this would be really cool user experience. In the beginning, the user doesn't even have to think about it, but when they scroll down, this thing pops up and they can see this cool animation. And at that point of time, I would like to tell my designer, would the user really like it though? Would they like it though? Have you seen how our users use things? Have you talked to customer support? Do you really want to give them jump scares? Really? But your designer is your designer, and be like, but it'll be so cool. I designed something. You scroll down, it would be amazing. And then this happens. Finally, you have an engineering reason to tell them, hey, your ideas are great, but engineering says. So displaying large amount of data, or whatever your designer feels like doing, sometimes if you have that kind of caching or lazy loading or whatever it is where initial perception of how the page render is slightly different from what once the user kind of interacts with it could happen, then keep that in mind. So again, another thing would be the non-discrete inputs. So non-discrete inputs is something that the user does not engage with directly. So a click is a discrete user input. Tapping a keyboard is a discrete user input. But scrolling through, hovering over, these are not considered discrete user inputs. So if you have a tooltip that pops up, I think it would still be considered as a part of your CLS core because it is a visual shift that the user did not expect. Sometimes they do. They see the tooltip icon, but maybe the calculation algorithm does not expect the user to expect it. And another condition, which I don't think these would be common, but I thought just to say it out loud anyway, is error conditions, especially error conditions which are unexpected, server error conditions, where you have a large list of data or images or something, and you expect kind of, maybe even in streaming, you have that kind of data coming in from the server, and at some point of time, the data just snaps off, and if you're not concerned about it, or if you're not clear about it, then the minute you have that kind of an error, if the full screen was this much, it'll pop down to just a text saying, oh, there was an error, there was an issue. But you should keep that kind of visual area perfect so that when the data reconnects again, you don't have that kind of an unexpected visual shift for your user. So there are so many different conditions in which these can happen, and I'm sure this is not exhaustive. There are other things that can happen very specifically for your application that I have not thought of. So this is just a principle of how to calculate it, what are the things you can keep in mind, so that hopefully when you see it next, you have an idea of how to tackle this, how to approach this. So now I'll be talking on to INP, and again, I hope you remember, Nishu talked about this, so I will be kind of zooming through this a little bit. And again, this is not a stable metric yet. This is still something that's going to be stable next year. So some of the things I'll be talking about, especially when it regards to INP, is a little bit of a hypothesis until we get real-time data from how users interact with it. I would like to touch upon the difference between FID, INP, especially when it comes to kind of the calculation of it. FID is the first interaction delay, so it only deals with the first time the user interacts with a page or content or something like that. And it did kind of slant towards LCP in terms of like a low responsiveness metric as well. But as I've noticed with INP kind of measures it for the full life cycle of the page, right? So rather than first impression, I feel like it really would sort of give a better scope of the user's interaction during the life cycle of the page. But again, we'll see. So going back to the kind of analysis that started it all, I hope you remember, LCP React didn't really change much when we had the whole data set and when we filtered it down to 1 million, right? FID didn't really matter that much because all the frameworks had like a really good ratio for FID. The one thing that React went markedly down on was the CLS, because React has some re-rendering kind of biases that come in with the virtual DOM. I will talk into that. But as we move from FID to INP, I do believe that React is one of the frameworks, because of the way React is structured with the virtual DOM and that kind of the way the DOM is set up, it could impact kind of two metrics at the same time as compared to how FID was measured, right? So if CLS was React's weak point in our previous analysis, moving forward, it could be that it does weak in two more metric as we calculate kind of how React does across the interaction throughout the lifecycle of the page. So, re-rendering, the final boss of all React problems. So, again, I would like to compare this with Vue. Vue and React, if you compare, one of the biggest things is how Vue, when you have the re-rendering, the compiler, you can sort of have optimization both at compile time and at runtime. But in React, you can only have that kind of optimization in compile time. React is unable to optimize during runtime. So any runtime kind of re-rendering that you have to do, it has to traverse through the DOM tree again and again. And that is also why we can have that kind of a re-rendering issues, if you may, when you don't pay attention to how your React state management or your data management is done incorrectly. And don't worry, I do have examples of how things can go very wrong. Fun part of my job. So we go back to how things were perfect in my application when I introduced Redux, right? Everything was independent. If I wanted to change versions, I could just change only the locations, only the roles, and it was all perfect. But then you realize some things have interdependencies. So for example, once the role changes, we have to change the costumes. Makes no sense to have the costumes for Winston or the costumes for John Wick if I change John Wick is played from Keanu Reeves to Halle Berry, right? So there are some dependencies between these data. They are not completely independent of each other. Again, for props, based on how the location changes, I do want to change the props used in a particular scene. So each of these data points is not as isolated as I would like to believe. So if I do have such a condition, how do I solve it? In React, there is a very simple solution when you have dependencies. What is that? We use a use effect. Very simple solution in React is you have a use effect hook, and a use effect hook, what it essentially does is that I would write a level of code where, okay, this very specific thing, in this case, for costumes, that's a role ID. So once a role ID changes, now everything in the square brackets is always a dependency. So the minute the role ID changes, I want you to refresh the costumes. So this runs every single time anything in the square brackets changes. So first case, dependencies, I add a use effect. I have more complexity. I bring in one more data item, which is makeup, and makeup is connected to both costumes and to location. What would this cause? This would cause a re-rendering mess, kind of similar to what we had when I had use context. Now you can see, we started out thinking context was perfect, but then context was not good enough. So I switched to Redux, thinking, hey, Redux has more of a fine-tuned control over my data. But as more features come in, as more iterations come in, you can see how as much as you want re-rendering to be perfect and as much as you optimize for it, as features come in, you can run into these scenarios where, yes, at the virtue of your previous kind of scope, you do run into this kind of re-rendering problem, for lack of a better term. So how would that be termed? I believe it's called layout thrashing. So there is a lot more that I would like to talk about. Unfortunately, I do not have time for when it comes to layout thrashing and that kind of calculations and what it takes and why React is especially poor at it. And that fundamentally comes down to, as we said, during runtime, React doesn't optimize as well. So based on how your data is structured, the minute you add more dependencies to it, it could cause that kind of a chain reaction that re-renders a lot of things. One point I would like to note, if you are facing this kind of a layout thrashing kind of a scenario, one thing you can do is use the profiler. I believe if you use Google Chrome, it shows up in like a lovely purple color. So you can see the different points at which the layout calculation is happening, where that kind of a sort of crisis is happening in your specific scenario. And those are kind of the scenarios that, or places that you have to look into and the places you have to optimize when that kind of thrashing occurs. So I would like to give a very special mention to use layout effect. Use layout effect is something it is similar to use effect, to be honest, but it fires quite before the browser repaints the scene. Now, if anybody knows anything about layout thrashing, that you can see where things can already start to go wrong because you want to minimize the number of times that kind of an effect happens. But there are cases for which use layout effect is the right deal to do. For example, things like tooltip. Now, imagine you have an entire application and you want to show a tooltip, right? You want to be able to render that tooltip somewhere, calculate the height and width of it, and then again re-render it as the window paints so that it is on the right side, like above the icon, below the icon, whatever it is. So there are cases in which even things that generally the community says, please don't use, because there are cases in which things should be used. Nothing is evil, nothing is bad performance-wise. It is just, it would be bad if you use it the wrong way. It would be bad if you use layout effect in the place of use effect just because they look similar, right? It would be bad if you used React context in the place of Redux just because I don't want to add a new library, right? So each tool has its own place in the React kind of pantheon, but be very careful when you use these hooks and be sure about what kind of consequences they have when you use them in your specific scenarios. So I do have a few minutes, so I would like to talk about some React-specific methods to improve that kind of a layout thrashing problem that I faced earlier on. And the first kind of optimization method I'd like to talk about is React Memo. So React Memo is a kind of a React tool to reduce the re-renders of a full functional component. So compared to, there is a specific one that you can use for a function, there is something else that you can use for a value, but very specifically for a functional component, to stop a component re-rendering again and again, to avoid that kind of full, if your layout, for example, is held within a single component and you don't want it to re-render again and again. And in the scenario I mentioned before, the minute I introduce makeup into it, there are a bunch of other interconnected ones that could re-render again and again. So I want to make that kind of re-rendering more conditional, more fine-tuned. I would use something like React Memo in those cases. And I do have an example coming up, but just for people who are not as familiar with React, I just want to give a quick overview. Memo is a customization option in the Memo basically lets you have a customizable function right after the component. So how it's done is basically you give a functional component, it does whatever the component is supposed to do, and then by default, you do not need to, because by default, React kind of compares all of the props that that component has, and it says, okay, if none of these props change, the component is cached, and it will be memoized, and it will just show it again without completely re-rendering it. But there could be some scenarios in which you want to give a very custom kind of memoization function. So let's go into that. So here is a use case that we had. So for example, I showed you a bunch of data. We have data for the different roles in a script, different costumes in a script. And one of our clients wanted like different views of the same data. Right? They wanted it in thumbnails. They wanted it in a table. But at the end of the day, the data is not doing anything different. The only thing that is changing is just how the client looks at it. So we used React Memo in that kind of a scenario where absolutely nothing was changing except how we showed it, so that the component underneath, which was making that kind of calculation and having that kind of data, would not re-render. It's just that the final parent component, which was rendering that kind of data, that was the only thing that was re-rendering again and again. So that is one, again, a scenario, an example. So an example would be, in this case, we have costumes, and I'm not going to show you all the code. This is, again, scenarios and things that you can consider. So I have my costumes. They are connected to both roles and location. So what do I want from my costume? If the particular role ID, which means these costumes are connected to a single role and to a single location. If the location changes or the role changes, I want that costume component to re-render. But as long as those two remain the same, no matter what else changes, I don't care. Costumes should not be re-rendering it. We should have that kind of fine-grained control over how my costumes are displayed in my application. So I did mention that we can do this for methods as well as for values. How would I do it for a function? I would use a use callback. A use callback is, again, once you get one of these kind of memoization techniques, they are quite similar. It's just that each are recommended for a very specific use case. So there is use callback, and the next one I'm going to talk about is use memo. These are both React hooks. So there is no conditional rendering of these things. They can only render in the top level of your component. So how does use callback work? Let me show you with an example. So I have an actor profile, and I want to do kind of a size conversion for an actor. So what would that change? Every time the costume every time the actor changes, or every time the target country changes where the actor is, I want that kind of a size conversion to happen again. Those should be the only two cases where that method is re-rendered. Until then, okay, I missed something, my bad. So what does React callback give you back? You basically enter a function, and what React callback gives you is a function that is kind of memoized. So no matter what input you give into it, as long as the dependencies don't change, it would still give you a function that gives you a very specific processing of the input that you give. So coming back to the example, as long as whatever costume list I give, it should have the conversion, but this conversion should change when the actor ID changes, right? When the actor changes or the location changes, I want the size conversion to change. So the last one I have for you is use memo, very similar to use callback, but instead of having a method there, I just have a value calculation. So here, one thing I'd like to note is that the role details, that one thing is under a loop. So as you remember, for hooks, you cannot do it conditionally. So I kind of took it out into a component by itself as role details, and I ran use memo inside the component, so that I would avoid that kind of a conditional rendering of use memo inside a loop. So at the end of the day, what does this all come down to? You will always have dependencies, especially when you use React and that kind of a React framework to do your re-rendering and your component management. You will always have dependencies that will always cause re-rendering, but do keep an eye out on where the most re-rendering happens, where your dependencies are. And this is just a starting point. Again, there is no silver bullets to this. Keep these techniques in your mind, use them, go forth and prosper. That is it from my side. And I will be taking your questions pretty soon. Thank you.
Keerthana, yeah, thank you so much.
Thank you.
I think we've got a time for probably just a couple of questions. Let's do that awkward perching on the stool thing and try I might just lean this time. I don't know.
Accessibility.
Yeah, exactly. Yeah. There we go. Awesome. So, yeah, there's so much. First of all, there's so much in that talk. It's really dense and full of great stuff. So, thank you ever so much for that. One of the things, I mean, you're showing lots of techniques and lots of tools that are available to you as a React developer to address particular aspects of performance. But I guess one of my questions might be about keeping that in mind in the first place, because there are so many ways that you can build with React, or indeed with any tool, right? So although you've got access to all of these techniques that you can use, are there any things that you particularly like that help you while you're developing something to keep performance in mind? I mean, are there ways that it exposes to you what the implications are that you're creating by building in a certain way? What makes performance visible to you as a developer, I guess, is the question.
That's a really good question, and I'm just thinking about it right now. To be honest with you, I think there is a major difference. One thing about React is, again, as you mentioned, there's so many ways to do things. React really is the wild, wild west of web frameworks, and you really need a sheriff in town to tell you, this is the performant way, please don't do it the other way.
Right.
So it's really hard to kind of do that as a developer, but one kind of, and there is a big difference between if you have a legacy system versus if you're building something brand new. Because if you have something with older React versions like 16 and above, I am not as familiar with that code, so I couldn't think of kind of the same ways in which I would do it.
Right.
But for code which does have hooks, I would think one thing I keep in mind is how many use effects I use.
Right.
How many times I have that kind of hooks which have dependencies, and if if I start to see there is too many, that's when I have to sit down, at least with the rest of my team, with my management, like, hey, maybe it's time to rethink some of our data structures because we are having too many conditional calls and dependencies happening in the way we do things right now.
Absolutely, yeah. And I guess another symptom of all of these tools available to us, and this is one of the questions that came in actually, is in your opinion, do you think that frameworks like this are helping? Are they making it easier for us as developers to make sites that perform well, or are they making it harder for us to make sites that perform well because of the power that they encompass? That's a bit of a gut check and an opinion as much as anything else.
It is. It depends. The $100 billion word.
There it is. That's perfectly fine. Yeah.
But as I mentioned in one of my slides, there is a reason why all of these top websites are still doing so bad in performance, because they have so many features. There are so many expectations when you're a highly used website from the users. They want to give third-party stuff. You want to have all those things that users enjoy using, but those things, they take iframes, they take JavaScript, they take third-party libraries. So if there is a better way to do it, which we will probably find out throughout the years, but currently it's all we have. We just keep getting better at it.
Fair enough. Okay, excellent. Well, thank you so much again for a wonderful talk. Are you going to be around in the break to talk to people up at the table? Thank you ever so much. So yeah, we didn't get to your questions. Apologies for that, but make sure you find Keerthana upstairs after the break. So once again, thanks so much for a wonderful talk. Keerthana Krishnan, everyone. Thanks so much.
Thank you.